Hey everyone, welcome back to Coding with Chan. Today we are covering one of the most important concepts in distributed systems, CAP Theorem. If you have ever faced a system design interview or worked with distributed databases, you have probably heard of it. By the end of this video, you'll understand what CAP means, why it exists, and how to decide between different trade-offs. Let's start with the problem CAP was created to solve. Imagine sending 500 rupees through UPI. Your app says payment successful, but your friend never receives the money. What happened? Behind the scenes, multiple servers are involved. One server updated your balance, but another server hasn't received that update yet. When servers disagree because they can't communicate properly, distributed systems face a difficult decision. That's exactly the problem CAP theorem explains. This situation is called a network partition. The servers haven't crashed. They are both running. But the connection between them is broken. Now the system has two choices: keep responding and risk showing outdated data, or stop responding until the servers synchronize. There's no perfect solution, and CAP theorem describes this trade-off. CAP stands for consistency, availability, and partition tolerance. Consistency means every user sees the latest data. Availability means every request gets a response. Partition tolerance means the system continues working even when servers can't communicate. During a network partition, you can't guarantee all three. Since partitions are unavoidable, the real choice is between consistency and availability. Consistency means every server returns the same data. If your balance becomes 500 rupees, every node should show 500 rupees. To guarantee this, servers synchronize before responding. That keeps the data correct, but it also increases latency. During a partition, the system may reject requests instead of returning incorrect information. That's why consistency is critical for banking and payment systems. Availability guarantees every request gets a response, even if the data is slightly outdated. If one server still has an old balance, it responds with that value instead of returning an error. This is acceptable for applications like search engines, social media feeds, or product catalogs, where temporary stale data is better than downtime. Network failures are inevitable. Data centers lose connectivity, routers fail, and cloud regions become unreachable. That's why every distributed system must tolerate partitions. Once a partition happens, you have to decide whether consistency or availability is more important. A CP system prioritizes consistency. During a partition, it may reject requests to avoid serving incorrect data. That's ideal for banking payments and inventory. An AP system prioritizes availability. It always responds even if the data is temporarily stale. That's perfect for social media, search engines, and review platforms. The right choice depends on your business requirements. Real databases follow these trade-offs. MongoDB, HBase, ZooKeeper, and CockroachDB prioritize consistency. Cassandra, DynamoDB, React, and CouchDB prioritize availability. Many modern databases also let you configure consistency levels depending on your application's needs. Let's recap. First, network partitions are inevitable. Second, partition tolerance isn't optional in distributed systems. And finally, During a partition, you must choose between consistency and availability. You can't fully guarantee both. That's the essence of CAP theorem. If this helped you understand CAP theorem, don't forget to like the video and subscribe for more system design content. If there's another concept you'd like me to cover, let me know in the comments. Thanks for watching, and I'll see you in the next one.